In question 14 we have 2 meter scales. We need to calculate the ratio of aluminum centimeter to steel centimeter. Solution 14. So first of all, steel and aluminum, they have same length at 20 degree Celsius. Now the coefficient of expansion for aluminum is 2.3 into 10 to the power minus 5 per degree Celsius, and then it will be 1 minus alpha steel into 20. It will be equal to LOAL 1 minus alpha AL into 20. This is the temperature 20 at 20 degrees Celsius. A part ratio will be 1 minus this should be aluminum, this should be steel, 1 minus steel into 20. So 1 minus 2.3 into 10 to the power minus 5 into 20 over 1 minus 1.1 into 10 to the power minus 5 into 20. So this ratio will come out to be around 0.999. And in second scenario it will come out at this temperature, it will come out 40. So it will come out again around 0.99. So L length of alumina over steel into 1 plus 0.3 into 10 to the power minus 5 into 10 over 273. It will give us around 1.00025. And length of aluminum over steel one plus alpha 200, 1 plus alpha steel 200. It will come out to be around 1.00096. In question 15, meter scale is given. What will be the percentage error in the scale in various situations? Solution 15. A part, length at 16 degrees Celsius. We need to find this length. Temperature is 16 degrees Celsius. T2 will be 46 degrees Celsius. So let's put everything. Del L equal to L alpha del T. So from this L 1.1 into 10 to the power minus 5 into temperature differences of 30 degrees, 46 minus 16. Now after this the percentage error will be del L over L into 100%, 0.99977, 1.0092, or if we write in the formula into 100 into percent, so it will be 1.1 into 10 to the power minus 5 into 30 into 100%, which will be 0.033%. In second scenario, T2 is 6 degrees Celsius So it will be L alpha del T over L into 100%. 1.1 into 10 to the power minus 5 into 10 into 100 minus 0.011%. In question 16, meter scale is given. We need to find the range of temperature in which the experiment can be performed with this meter scale. Solution 16. Del L equal to L naught alpha del T 0.055 into 10 to the power minus 3 equal to 1 into 1.1 to 10 to the power minus 6 into T1 plus T2. 0.055 11 into 10 to the power minus 3 into 20 plus minus 11 into 10 to the power 3 into T2. So T2 will be around 20 plus 5, 25 degree, or 20 minus 5, 15 degree. In question 17, we need to calculate average coefficient of volume expansion of water. Solution 17. So at 0 degrees Celsius, the density is 0.098 gram per centimeter cube. At 4 degrees Celsius, it is 1 gram per centimeter cube. So ultimately 1 plus gamma del T, so 0.098 equal to 1 over 1 plus gamma into 4. So gamma will come out to be around 5 into 10 to the power minus 4. So density decreased by this much. In 18, we need to find ratio of length of iron rod to aluminum rod. Solution 18. So L dash for iron 1 plus alpha Fe del T, and for aluminium plus Al del T. So let's subtract these two equations, we will get this thing. So by this the ratio will come out to be 23 by 12. In question 19, a pendulum clock is given. At what temperature will it give correct time? You have to tell. Solution 19. So 2 pi root L1 G1, 2 pi root L2 G2. So we will have 2 pi root L1 G1, which will be equal to, the change in the length will be equal to 1 plus del T over G2. This will be the case that we will have. So ultimately when we put the values, we will obtain 9.788 over 9.8 equal minus 1 equal to 12 into 10 to the power minus 6 del T. So ultimately del T will come out minus 0.00122. So it will give us T2 to be equal to, now we will have two situations by the way. So let's separate those two situations. One is this situation and one is this situation. So here T2 will come minus 101 degrees Celsius and here 9.788. So 1 over 9.8 point minus 6 del T, 9.788. T2 will be minus 82 degrees Celsius. This will be the answer. Question 20. Aluminum plate fixed in horizontal position is there. At what temperature will the ball fall down? Solution 20. So in this question we will have this scenario. Del T 1 plus alpha Al del T. So ultimately this will be there. So when we put the value we will obtain this thing, and this alpha Al del T. So here 2 into 23 into 10 to the power minus 6 del T. 2.005 plus 2.005 into 11 into 10 to the power minus 6 del T. 2 plus 2 into 20 minus 6 del T. So del T will be 208.81. Del T equal to T21 minus T1. So T2 will be del T plus T1, 208.81 plus 10, so T2 will be 281, 218.81. In question 18, glass window is to be fit. What should be the size of aluminum frame so that there is no stress on the glass in winter even if temperature drops to 0 degrees Celsius? Solution 21. So here 1 minus L del T 20 del T. Let's call this del theta so that we do not get confused in them. Or let it be del T because they are same. So 1 minus 24 into 10 to the power minus 6 into 40 equal to 21 minus 9 into 10 to the power minus 6 into 40. So L will come out to be 20.012 centimeter. Let initial n be B. So now in this scenario we will find B to be equal to 30.018 centimeter. In question 22, volume of glass vessel is there. What volume of mercury should be poured into it at its temperature so that volume of remaining space does not change with temperature? Solution 22. So in this scenario, volume of gas volume of mercury so subtracting them we get this so VHG equal to 9 into 10 to the power minus 3 1.8 into 10 to the power minus 4 500 cubic centimeter. In question 23 aluminum can is given. Find the rise in water level. Solution 23. So in this scenario we will have this equation 1 plus gamma del T 3.2 into 10 to the power minus 4 80 minus 10 so it will be 511.2 centimeter cube. This will be the volume. So increase in volume is this much. Increase in volume 11.2 centimeter cube. 511 minus 500. So height will increase 11.2 by 125, that is 0.089 centimeter. In 24 we need to calculate coefficient of volume expansion of mercury. Solution 24. So we will use this equation. So when we put all the values here, we will obtain gamma G to be this much. In question 25, densities are given. At what temperature will the piece of wood just sink in benzene? Solution 25. So we will use this weight of the sphere equal to displaced water. The buoyant force will be equal to displaced water. So V density of water into G equal to V density of wall into G. So we will obtain something like this. (880) over 1 plus 1.2 into 10 to the power minus 3 del T. 900 over 1 plus 1.5 into 10 to the power minus 3 del T. So del T will come out to be 83.3 degrees Celsius, around 83 degrees Celsius. In 26, a steel rod is given. What is the longitudinal strain developed? Solution 26. So del L will have 100 degree Celsius. So there will not be any strain, longitudinal strain, because there is no opposition to expansion. So no strain in longitudinal direction. In question 27, steel rod is given. Rod is unstrained. Find the longitudinal strain. Solution 27. So strain will be del L by L, L alpha del T by L alpha del T. 1.2 into 10 to the power minus 5 into 50 minus 20, which will give us 3.6 into 10 to the power minus 4. This will be the strain developed. In question 28, determine the tension when the temperature falls to 0 degree. Solution 28. So L alpha del T will be FL over AY. F will be alpha del T AY 1.2 into 10 to the power minus 5. 20 minus 0, 0.5 into 10 to the power minus 5. 2 into 10 to the power 11. 24 Newton. In question 29, steel rod is there. What force will the rod exert on one of the clamps? Solution 29. So force over area over strain will be Young's modulus. It will be y del L by L into L. So it will come out to be around 384 Newton. When we put all the value, this will get converted into A alpha del T. In question 30, we need to find length of system when the temperature is raised to theta. So this is solution. So strain of system will be L1 minus L0 by L theta. Total strain of system will be total stress of system, total Young's modulus of system. Total stress will be stress due to two steel rods plus stress due to aluminum one. Gamma S alpha S T gamma S ds T phi Al. So alpha Al T. So Young's modulus will be this. Strain of the system will be L theta minus L0 over L theta. L0 will L theta will be L0 y Al 2 alpha S y S into T over this. In question 31, steel ball is there and find the pressure inside the ball. Solution 31, del V over V beta del V over V beta gamma del T beta 3 alpha del T. So when we put all the values, we will get 5.8 into 10 to the power 8 pascals. In question 32, show that moment of inertia of solid body of any shape changes with temperature by this formula. Solution 32. So let the radius of gyration be this much, and moment of inertia of at temperature is mr square 1 plus alpha t square mr square 1 plus 2 alpha t for approximation. So we prove this, that I dash equal to I naught 1 plus 2 alpha t. In 33, torsional pendulum is there. Find the percentage change in time period. Solution 33. So at 5 degrees Celsius, at 45 degrees Celsius, temperature will be 1 plus 2 alpha del T. Okay, 2 pi root 1 plus 2 alpha del T. Okay, so when we put the values, it will be I naught 1 plus 10 alpha over K, I naught 1 plus 90 alpha over K. So taking the ratio, we will obtain 1.00216 over 0.00024. Percentage change will be T2 by T1 minus 1 into 100, 0.0959% or 9.6 into 10 to the power minus 2%. In question 34, circular disc is there. Calculate the percentage change in the linear speed of the particle of the ring. Solution 34. So V by R equal to V dash by R dash. V dash over 1.00036 R. Percentage change 1.00036 V minus V over V. It will come out to be 3.6 into 10 to the power minus 2 into 100 also.